Okay, so if you have two non-parallel forces, say P and Q, acting at a point, using the parallelogram law, you can find the resultant of these two results, right? If the forces are parallel and acting on the same point, say P at this point, and there will be a Q, the resultant will be P minus Q or Q minus P, right? If they are on the same line of action, right? But now, since we are considering rigid bodies, the forces can act any point on the plane. So what happens if the two forces are parallel, say P and Q? Imagine these are parallel lines, not wiggly as this. If these two are parallel forces but not acting on the same line of action, these two have different line of actions, you can see. So if these two are parallel, this will not meet at a point, hence we cannot use the law of parallelogram of forces in order to find the resultant of these two. So we have to come up with a different theory, right? So I'm not going to derive it here. If you want, I can derive it later on the class, since we are in the vacation, so we have to limit our theories. Okay, fun stuff later. Okay, if there are two parallel forces, say P, you can't see, P, right, and there will be a Q parallel to this. I'm going to draw it a little bit bigger than P. Okay, so if the two parallel forces are like this, these are called like forces because the forces acting are in this direction, right, in the same direction but at different points. Say this is acting at A and this is acting at B, right? So the resultant forces of these two will act in between these two points. So I'm going to draw the line of action of the two forces, and this line of action will cut line AB at C, right? So the resultant, like before, will be P plus Q. Now since these two have different application points, the P plus Q have a different application point also. Okay, but how do we find the point C here, right? That's a good question. So I will derive it later if you want. And the theory says that, okay, I'm going to write it here, P into P is the force into AC. AC is the distance here, right? AC is equal to Q into BC, right? So the resultant of these two, or the line of action of the resultant of these two forces P and Q will select a point that cuts AB line such that P into AC equals to Q into BC, right? Okay, notice this. When Q is larger than P, the line of action tends towards Q. Okay, so if P is greater than Q, the line of action of the resultant will move towards A, right? So keep that in mind, and I'm going to stop it here.